Hey guys, so today we are looking at a single problem. This is kind of inspired by the super pink moon that happened last week. And no, it's not actually pink, but that was one of our super moons this year. And this kind of goes into what a supermoon is, why we have them, and then there's an article here. It's very, very neat. Um, so take the time to read that. It's definitely worth it. And then here is my prompt to you. That the above link takes you to an article from space.com about supermoons, mini-moons, and the orbit of the moon. If you ask me, it's incredibly fascinating. But we know that the moon itself stays the same size because, it's a giant rock and rocks don't really grow or shrink. But its distance from Earth affects how large we perceive it to be. And so in this article, this scientist, he uses two photos of the moon taken with the same equipment at the same location during both a supermoon and a mini moon. And so I went ahead and measure these to the nearest eighth of an inch using the Google Docs or the Google Drawings. And so now you're going to calculate the percent of change in the visible area. And so if you think about that, think about it like a light source, right? So I showed you this lamp the other day. This lamp is a pretty small light source. But if it were, 5 inches bigger around, then its area would be exponentially larger. And its volume would be exponentially larger than that. And so that amount of change would really affect the size of the room that it could light up. So that same thing here, because we know that in the night sky, the moon reflects light off of the sun, bouncing off at all kinds of angles. And that's what gives us our night light, I guess. So how much bigger percentage-wise is the biggest full moon compared to the smallest full moon? And again, if you go back up to the top, it talks about mini moons, which is very, very neat. I've given you the formulas that you would need. The area of a circle, remember, cherry pie is delicious, apple pies are too. And the percent of change formula, which is the amount of change divided by the original amount, and then that gives you a decimal. And then you whoop it, and it turns into a percent. And so in this case, I have actually given you a more specific a more specific percent of change formula. So please give your answer and explain, capital letters, it means it's important. Explain your process in the text box below. All right, so make sure that you do this. It is just the one problem, like I said. If you have any questions about where to start, watch this video again, and then you can email me. All right, so you guys have a great weekend, and we'll talk to you Monday. Bye-bye.